There we go. That makes that go away. So we're talking about all the different quadrants. I'll just erase it here, but that's 1. Remember, this is 2, 3, and 4, just to refresh our memory about the different quadrants. We talked already about stuff that's happening in that quadrant. Today we're going to talk about the rest. Reference angle. This is going to be a big word. Another big word is terminal arm. This is the terminal arm. And the angle here is formed by how far away is the terminal arm from the positive x-axis. So an angle of 0 degrees would start with the terminal arm sitting right on top of the x-axis. So if I do the terminal arm in, I don't know, that barfy green, there we go. That means the angle is equal to 0 degrees. Right, and then we move that angle up from there. So this is the terminal arm. We migrate in a counterclockwise direction. In this case, we opened up a total of 35 degrees. You don't have to stop at 90. You can keep going. And so here, we again started there. That was 0. And we opened up and up and up and up and up and up, eventually stopping here. So there's the terminal arm. We opened 145 degrees. So that's the angle. But if we were to reflect that in the y-axis and bring it back, it would reflect like this. This angle here would be 35 degrees. That is the reference angle. The exact same description, just using different words, is the terminal arm to the nearest x-axis makes the reference angle. Well, what is all the way from here all the way to that x-axis? How many degrees is that?
180.
That's right, it's 180 degrees. So in other words, what we're going to do is we're going to take 180 degrees, we're going to take away the angle, in this case 145, and it leaves us with 35 degrees, which is the reference angle. But it's not always take away. Because what happens in this circumstance, we went past the 180. Here, it's 215 degrees. So in this case, it's going to be the 215 take away the 180, which would give us 35 degrees. That's the reference angle. That's the actual angle. Well, there's one more angle we can make with the same reference angle. And that's this reference angle here, because it's the distance between your terminal arm and the nearest x-axis. We could go all the way around before we get that 35 left over. Fairly straightforward? I think it shouldn't be overly difficult. Let's just tidy this all up here. And let's draw, you do a nice clean one, It's not one of the official examples. We just do a nice clean one here. And we're going to say a reference angle equals, let's make it 40 degrees. I want you to draw all the possible angles that could have a reference angle of 40 degrees. So the first one, do it in red, it's going to be there. 40 degrees. The next one, I'll do it in purple, is going to go all the way around like this and stop over here. So that's 40 degrees, which means how big's my purple angle? 140. It has to be 180 minus the reference angle. So I didn't quite get to the 180, right? But we could have another one. I'll do it in green. Let's pick a funky green. And we could go all the way around, only this time we're going to stop here because, again, the reference angle is to the nearest x-axis would be 40 degrees. What's the entire angle this time? It's going to be the 180 plus the 40 this time, which is going to be 220 degrees. And there's one last one. See if you can figure out the last one on your own. We're going to go all the way around to here. And there's the 40. Distance to the nearest x-axis, right? Well, how many degrees is it all the way around the circle? 360. But how far away am I from the full 360? I'm 40 away from it, so how far did I actually make it? 320 degrees. So my four angles are 40, 140, 220, and 320. Easy enough? Yeah, it should be fairly simple. It's just examples. Distance to the x-axis. So that's your reference angle. Distance to the x-axis. Reference angle. Distance to the x-axis. Reference angle. Ooh. This is important. This is really important. Write this down. Notice it's just the three: sine, cos, and tan. But their sign changes depending on which quadrant you're in. You get two options with a diagram like this. Number one is you memorize it. Number two, you come up with some funky way to remind yourself what it is. Number three, you understand it. That way you can draw the diagram anytime you like. The one way that I saw, I've never seen this, I didn't learn this when I was a kid, but the one way I saw it was actually on the internet, was all students take calculus. What did you get?
I said you got sacked.
Yeah. Or cast.
Yeah.
Only it's in the wrong order. As long as you can remember, what those are is the positive ones. So A is all, and then its sine is positive, tan is positive, cos is positive. The others are all negative. So that's one way to use it to remember. Remember this diagram, this one that I drew, that's from 6.1? You remember that one? You remember how x is actually the cosine of the angle? If that's 1. Otherwise, it's r cos of the angle. Right? So if we just keep it simple and we just declare, no, that's just going to be 1. The x is the cosine. Because x is actually this distance here, right? And what do we call that side of the right triangle? That's the adjacent, because it's part of the angle. It's beside it. So adjacent over hypotenuse, or adjacent over 1, or just simply the adjacent, that's cosine. This would be the opposite, which would be sine. Well, that's the height equal to y. So that's where these come from, right? They're built right into the graph. What if I put my angle over here, though? Let's do green one. I'll do an angle here, like this. So there's my reference angle. The other one's the same. It's just the same angle. What do I know about my x? My x value here is negative. But my y value is positive. So what's my cos in that side over there? Cos is the x. So over here, my cos is going to be negative, because it's negative x. Yeah. Y is the sign, right? Y is the sign, so y is positive. See? If I drew one down here, let's do let's do purple. Let's do one down here, like this. What's my x? It's negative, right? What's my y? Negative. My y is also negative. So both my sin and my cos are negative. And if I'm on the other side, which one's positive? The x, which is cos, and which one's negative? The y, which is the sine. So how do we deal with tan? Well, tan theta equals sin theta over cos theta. All right, so ka toa, opposite over adjacent. That's opposite, right? That's adjacent. So it's y, which is sin, over adjacent, which is cos. So sin over cos. Well, here, a plus over a plus is a plus. A plus over a negative is a negative over a negative is a, and a negative over a positive is a. See, it's all just simple algebra. It looks really funky and like scary and unique, but it all comes down to that very simple little diagram, the one that you learned from from theta, right? P cos theta and sin theta. It all comes from this same one. And you can build it anytime you need as a refresher. You don't need to just hardcore memorize that diagram. But it's there to help you if that's how you do it. Nothing new. Absolutely nothing new here. What does it mean? Back to that original diagram, right? Like that. What's this length here called? That's my x. What's this length here called? That's my y. Right? If I turned it into a triangle, there's the angle. It works the same in any of the quadrants. SOHCAHTOA. All right, let's do sine. Sine is opposite over adjacent. This one is the r. It's the radius of the circle that we would draw around the center.
Isn't it opposite over hypotenuse for sine?
Sorry, yes.
So,
Good. Thank you for paying attention. I'm 3 steps ahead of myself in my brain. And what's the opposite here? Y over the hypotenuse is r. See? No. Cos is the same. Tan is opposite over adjacent, so it's going to be y over x. How do I work this out? Pythagoras. Y squared plus x squared, or x squared plus y squared. Square root. So nothing new. Easy enough. Happy? It's what we did. Spent a lot of time with it in the previous day. So if we're okay with it, I want to just keep going, because this isn't even anything to do with what we're doing today.
what if you don't know r? And if you don't know r, then are you going to be given the angle?
It could be anything. If you don't know r, but you would have to know this point.
Okay.
So 3, 4. Right? That means that's a 3, that's a 4,
Okay, that's easy.
3 squared plus 4 squared, square root, and you get r.
Okay.
Right? And then you can also, once you have r, you can then do that over r to get the cos. So you can plug it in for any number at all. Well enough? Okay? It's kind of like someone died
It's because you're recording.
and everybody's... Is it really? Is it because I'm recording? You're all like
No, I'm just
absolutely
I've
terrified,
already-
quiet, silent?
I was just joking.
No? Did they serve bad food at lunch?
Yeah. No, I'm just kidding.
All right. Let's give her. Here's some questions.
It's Tuesday.
So we're outside the normal domain here. We're not just simply in quadrant 1. We're doing all the quadrants. But they work exactly the same. It's not a panic. So determine the primary trig ratios. That means I'm looking for sin, cos, tan. Those are the primary trig ratios. Sin, cos, tan. So let's start with the first one. Sin theta equals. Now it's of the reference angle. So I'm going to draw my triangle like so. Now I'll even pull the triangle out so that we can see what it looks like a little cleaner. So there's my angle, which I don't know yet what it is. What's my x? 2. It says right there my x is 2, which means that length is 2. What's my y? -5. Now we're going to need, because sine is the opposite over the hypotenuse, we're going to need to know that hypotenuse. So let's figure it out. That's right. So remember, r is equal to the square root of x squared plus y squared. Taken straight off the notes from before, it's just a squared plus b squared, and then square rooted to get rid of the c squared, or the hypotenuse squared. So it's the square root of 2 squared plus negative 5 squared. Are we panicked about that negative 5 under the root sign? Why not? Well, it's because we're squaring it first. What's going to happen when we square it? That's right, it goes away, because a negative and a negative is a positive. So it's legit, square root of 4 plus 25, which is square root of 29. You've done enough already. Can I simplify 29? No. If you could, do it. But we can't. Is it pretty? I happen to think it's kind of neat. So just leave it, square root 29. Don't go decimal on me. We want exact answers. Square root 29, that's my radius. So, let's fill it in here. Sine theta is equal to, what was the opposite? Remember, there's the angle that constrains this triangle. What's the opposite? Negative 5. Can't ever be the hypotenuse. And the hypotenuse was root 29. Are we done? No, why not? That's right. Now, I'll tell you, the book is going to actually leave the root in the bottom for an awful lot of these. Don't. It's easy enough to fix. Multiply both by root 29, the answer is minus 5 root 29 over 29. But if when you're checking your answers, and I really hope you're checking your answers all the time, don't do more than a question or two before you check your answers. If they've left it in the denominator, just make that noise. You know, the condescending one. Shake your head a little bit and think, I know better than this. But then move on. Cos, real quick on your own. Cos theta is adjacent over hypotenuse. And lastly, tan theta, opposite over adjacent. And there's your answers. And so far, really, you've not seen anything new. Just had it presented in a slightly different way. You guys all know SOHCAHTOA. You're good at SOHCAHTOA. Which one? The triangle is the same. I just plucked this and wrote it over here. Yes, yes. the same.
But using those to calculate down just for the inside.
Uh-huh. Same. Let's take a look and you'll see. Okay, determine the measure to the nearest degree. This is just the second part. This is part B of the same thing. We have three choices. Which one do you want to use? Sounds good to me. That's a really good choice. Why'd you pick it? Because there's no stupid stuff. Right on. So, tan theta is equal to 5 over 2. Negative 5 over 2, right? So, theta is equal to, how do I find the angle? Tan to the minus 1, right? 5 over 2, negative 5 over 2. And just stick in your calculator. And what do you have to make sure your calculator's in? Degrees. Oh, bugger. Mine's not again. There we go. And 10, negative 5 over 2 equals negative 68.2 degrees. Yes, of course. You don't need that. Okay. Negative 68.2 degrees, but what was it we worked out? We worked out so how big is that one? Well, we're comparing it to 360, right? That's if we went all the way around, take away 68.2 degrees, and what do we get? 291.8 degrees. Yes. No, actually you can't. How come? When you're working out a degree, you could, but not for this one. What does the question say?
To the nearest degree.
Very precisely, it says in the question. So what would this answer be? Brilliant. Absolutely perfect. Okay, and you do have to follow the instructions of the question. Put this in your notes. This is a little special stuff just for you. These are two special triangles. If you've bought a geometry kit, and I know for most of you, you have like 8 of them somewhere in your history. You probably have none in your possession, but you have purchased many throughout time. You will notice in your geometry kits that you had 2 triangle rulers. And you always wondered, why do I have 2 triangle rulers? Who would possibly use a triangle ruler? That's stupid.
You sound like, what's his name off of Zoolander, the main guy.
Oh, sorry. I won't ever do that again.
It's a good thing.
Ben Stiller.
Yeah.
Those 2 triangles are very, very special. The one is a 45-45 triangle, meaning it's an isosceles triangle. It's got 2 45-degree angles. And you know from like little people school, when you got an isosceles triangle, it means that these sides are the same length. So we're going to call them A. I don't know, because that's what the picture I stole called them. You could call them whatever you like. Kitty cat. Whatever. Doesn't matter. But the point is we know that they are the same length. And so if I did a little Pythagoras here, I would have a squared plus a squared equals the hypotenuse squared. The square root of a squared plus a squared equals the hypotenuse. What's a squared plus a squared? 2a squared equals the hypotenuse. What am I allowed to bring out? Well, I've got square root 2 and I got square root a squared, which means I have root 2a as my hypotenuse. That comes just simply from Pythagoras.
So is that root 2 times a, or?
Yes. It's the square root of 2 times a. Oh, I know, whatever. Okay, yeah, I didn't even actually notice that until just now. And that's terrible. I stole it, and I didn't even look that closely at it.
So is 60 supposed to be a 30?
Well, obviously, yeah, because you can see one's a 30-60 triangle and the other's. That's curious. Bad internet. So what would the answer be if they were 1? 45, right? It has to be 45 triangles. 1 and 1. We would get root 2. Because it's root 2 times 1, yes? A would be 1. All right, we're going to do exactly the same process. I'm not going to guide you through all the work. Just memorize this. A 30-60 triangle is A. The hypotenuse is 2a, and the opposite side, the longest side, is root 3a. So if it was 1, a standard 30-60 triangle is going to be 1, 2, root 3. The 45 triangle is 1, 1, root 2. Memorize those two triangles. They're really important. Don't copy this down right now. It's in your book. I know, because I took a screenshot and put it in here. But you'll notice there's 45 degrees right there. When we have 45 degrees, that's my cos. If it's a unit circle, right, with a radius of 1. It's root 2 over 2. Perfect. The sine, root 2 over 2. Because it's 45 degrees, so they're both the same, right? If it was a 135 degree circle, that's because that's the 45 reference angle. Notice it's exactly the same.
Except for the 10.
Well, then it's going to be negative. Right? And tan, because that and that are the same length, opposite over hypotenuse, or opposite over adjacent, no matter what those numbers are, it's going to be 1 because they're identical. But here it's negative 1 because one of them is minus. So this is a lot faster than you realize. We're going to draw two things. $60, 60, 60, 60. All right, those are my 4 reference angles, yes? What are the actual angles? We're going to have 60 degrees. What's the next one? 120. I think you got this. What's the next one?
180.
No.
Wait,
240. And the next one?
but it is 180.
300. All right, this one is 60 less than the 180. This one's 60 more than the 180. This one's 60 less than the 360. Fair enough? Now, these are 60-degree angles. So we're also now going to sketch ourselves a little, back to purple. There's my 60. There's my 30. This is 1. This is 2. This is square root of 3. And that you just have memorized. For the initial part while you're working, have it on a piece of paper next to you so you can refer to it. So in here, if I were to bring this down, that's my 60-degree angle. It's the same as this. How big is this right here? That's 1. This length is? No. This length is? Square root of 3. All right? I had to rotate the triangle. I had to flip the triangle around. But the hypotenuse is always going to be 2. That's square root of 3. My bad. Hypotenuse is 2, always. So if I came here and let's do this one, that's 2. The short length is 1, only it's negative, because it's in the negative side, yes. And this length is square root 3. What have we not done? We haven't done a blue. So here, this is negative root 3 now, because it's flipped upside down. This is 2. This is negative 1. And the other side, the last one, it's getting too busy. I'm not going to fill it in. On yours you could. So let's do the green one. What are my trig ratios? So, ka, toa. For 60 degrees, sine 60 is equal to? We're dealing with the green one right here. Opposite over hypotenuse, which is root 3 over 2. Cos 60 is equal to? Jenny, what's cos? Adjacent over hypotenuse. We're in the green triangle. Here's the angle. What's the adjacent? One. And what's hypotenuse? Tan 60. Mr. Troyer, let's go with you. Square root 3 over 1, which is just square root 3. Okay, that was for 60 degrees. We can now do the orange one, which is 120 degrees. Sin 120 equals, opposite is root 3 over 2. Cos 120 equals negative 1 over 2. Tan root 3 over negative 1, which is negative root 3. If you kept on going, I don't want to spend the time to do it, because we're short on time to get through this unit. If we kept on going through this, we would fill in the same set, and it would follow that pattern of that. Remember? All students take calculus. Plus, plus, plus. Only sine is positive. Cosine was negative. Tan was negative. But the values never changed. The values are all exactly the same. So the number's not going to be any different. It's just going to be which one is plus and which one is negative. Take out your graphing calculator. The very first thing I want you to do is to change your window. We're going to change our window from minus 30 on the x to 390. We're going to change our y from minus 1.1 to positive 1.1. We are going to now go y equals, and we're going to plot sin x. You ever looked at the graph of sin? Looks a lot like a map of Las Vegas. No, it doesn't now. It's just like funny, but obviously not really. Holy sweet moly!
Yeah, it looks like this.
Why is that working the way it is? Yours doesn't look like that, does it? No, mine has a heartbeat. It's alive. It's because in this calculator, I'm in radians. Let me fix it. There we go. That's what yours should look like. Clear your calculator. Reset it back to degrees. Do it again. Remember I showed you how to clear it with mem. Second function plus sign. And then go through the reset. Okay, what we got here is, I can't write on here, so just follow along. That was 0. That's minus 30. The reason we did minus 30 was just so we could see the line. That's 0. That's 360. Remember we took it all the way to 390? Because I wanted you to clearly see the 360. Watch what happens to the sine. As it goes up, 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 right at the peak. How many degrees would be? 90. And then if we keep on going, it falls back down to, what's that point right there? 180. And if we kept on going down here, it's going to be 270. And then all the way up to 360. And then it's going to continue again because you go around the circle another time. And another time. And another time. If you took it to 720, you would just get multiples. If you take it to 1,000,000, you just get lots. It just repeats over and over and over. What's the sign in the first quadrant? Plus. In the second quadrant? Plus. Third quadrant? Negative. Next quadrant? Negative. Check it out. We're going to hit trace on the graph. Ready? Boom! Trace. Yep, all around. 1. Hit trace. Now you can just type in a number. We just did 60 degrees, right? Type in 60. Hit enter. Boom! 0.866. Yeah, so what's 0.866? We just said root 3 over 2. Oh yeah? Really? Screen. Switch program. Boom. Here we go. Root 3. And then move my thing out of the way there. Divide by 2. Oh. This gives you all the answers in the graph. Right in the picture. What do you suppose it's going to look like for cos? Cos is plus here, right? If we're just doing cos, it's plus. Here it's negative. Here it's negative. Here it's positive, because that's C, right? What's the graph going to look like? Well, it's going to be plus, minus, minus, plus. It's exactly the same shape because the numbers are identical. It's just taking the opposite. It looks like that. The sine curve looks like that. Tan's a little funky. Tan's funky. You need to change your y's. Make them 10. Minus 10 plus 10 for tan. Y's. Yeah, your x's can remain the same. We're going to go minus 10 and 10. And you see, that's why we didn't do it for the sin, because sin can't get any bigger than 1. Neither can cos. But tan, if I change this now and I make it tan x, notice positive in the first quadrant, negative in the second quadrant, positive in the third quadrant, negative in the fourth quadrant. All right, all positive. There it is. Negative. All right. Here it's positive. And only the C is positive, so that means tan is negative. All right, your graphing calculator is going to be a huge help. It's really, really powerful for you. So I'll just clear all my ink. There we go. So there's the drawing essentially that we did. And if you use your x and y's, right, off of what we worked out from our special triangles, there's the chart of all the different values with the sin, cos, and tan all given. That's the first one that we did. All right? We worked out the second one, and the numbers are the same. They just change sign according to which quadrant you're in. Okay. Copy this really fast because we're so out of time. Ricky, get this done. Good. This is what you should have out with you while you're working your questions. What about all the other angles? And we're talking about the 3 other quadrants, so we've got all 4 in total. Just remember the plus minus, which is plus, which is minus, in which different section. But this is like your squares and your cubes and your fourth powers and your cube root and your square root and your fourth root, that little table that you made that you got hidden in the cover of your book. You could slip this in the cover of your book and just use it as a reference. Of course, you can't use it on the test, but hopefully the more you see it, you just remember it. And if you memorize those special triangles, and for whatever reason you forget, you just sketch out a special triangle and you can calculate it real fast. We all good? I can move on? All right. Those are your graphs. All right, these notes are available for you. This stuff isn't in the textbook, but you can draw those graphs on your calculator. You all have a calculator at any given point, so you can refresh. Plus, plus, minus, minus, right? Plus, minus, minus, plus, if you forget. So you have a huge tool with you. So, what values of theta are going to satisfy cos theta equals negative 3 over 4? Well, to be honest, you have a humongously powerful tool in front of you. Use the bloody thing. You have access to it. So I'm going to encourage you to use it. We're going to graph cos theta. So I have a funny feeling that, yep, mine dies every time. Okay, there we go. So y equals cos theta, and I just need to change my window. I'm going to go minus 1 point, oh no, yeah, so that's minus 30 to 390 minus 1.1 and positive 1.1, and I'm going to graph it. There's my cosine graph. So tell me, what do I need here? No, don't do that. No, go back. Screen, switch programs. No, wrong thing. Open up. Okay. Again, whereabouts on here? Let's use my little laser. Where would negative 3/4 be? There's no numbers along here, but remember what was the bottom?
Like the whole time?
When we redid our window? Right, we set our y, that's 0. What did I make my bottom? Negative 1.1. And the reason for that little bit is just so I can see the bottom of the graph. So that little tick is negative 1. Where would negative 3/4 be? 3/4 the way along, right? You can plot it. Let's do it. Go quickly. Y equals. Do another one here, and we're going to call it negative 3/4 equals. Well, we need equals. And there's graphing. That's a negative 3/4. Well, how do I figure out what that point is? I'm going to go second function, calc, right, on the trace button. And I'm looking for the intersect, where they cross. So scroll down. Scooch just to the left of where they intersect. Hit enter. It should be really, really close. It's kind of hidden behind the writing there, but it is really, really close. Boom. There's my answer. 138.59 degrees. Which to the nearest degree would be 139 degrees. Do it again. Second function. Calc. Intersect. Scooch this way all the way over here till we're close. 221.4. 221 degrees. So we had 139 degrees, and I already forgot what it was. 221 degrees. Where's your work showing here? I will absolutely accept that you sketch me the graph.
Was our sketch diagram to be accurate?
It has to be realistic, not like anal retentive, don't spend an hour, but it has to be reasonably clean. Which for some is going to be a challenge, I know, I've seen you already. For others, don't waste like an hour drawing the graph. Has to be good enough that I can see what it, because I know what it looks like, but I can see that you drew it from exactly the right spots. Now here's your proof. Where is cosine negative? Remember in the first quadrant, everything's positive, so there's nothing there. Cosine is negative here and here, yes? Which means it's going to be symmetrical around what angle? Around the 180. So your first one you worked out was 139, right? Well, how far away is that from 180? 41 degrees? Which means it's going to be 41 degrees here too. It's going to have the same reference angle. 180 plus 41 is 221. They have to be exactly the same distance because everything's perfectly symmetrical. Easy enough? Use the tech. You have it by all means. Use it. You pay for it. Make use of the thing. So I need to see the graph drawn though in order to give you credit for work. Yes? Yeah, absolutely. Yeah. Cos is equal to the adjacent over the hypotenuse equals negative 3 over 4. So you can work it out. You can draw the picture, right? Adjacent is this one here, so that's going to be negative 3. That's the opposite, sorry. Negative 3. The hypotenuse is 4. Stick it in your calculator. You got your calculator with you? No, she can't even do it. No, anyways. Okay, but go ahead, plug it in, because we're looking cos of theta is equal to negative 3 over 4. So theta is equal to cos to the negative 1. All right, 3 over 4. Maybe just borrow Jenny's real quick and run through it. So cos to the negative 1, second function cos. And you get that 41 degrees. Right? But you remember that 41 that you worked out is the reference angle. You couple that with knowing it's negative, so it's on that far side in quadrant 2. Subtract it from 180, and that tells you the actual angle. Fair enough? On your own. If you use the graph here, remember set your windows 10 and 10. Because otherwise you may not... Well, although, no, you would. Even if you left it, you'd be able to see it, because it would intersect. So the graph kind of looks like this. And it's positive 5/12, which means your intersection points are going to be there and there. That was the 180 mark. That's the 90 mark. So if you did 10 to the negative 1 of 5/12 equals alpha, that's the symbol for alpha. Second function 10, 5 divided by 12, 22.6. We know the first point, because it is from there, is going to be 22.6 degrees. The second one is 22.6 degrees away from what? It's ahead of the 180. So I would have to add 180 to that, and we get 202.6. So those are my numbers. If we did this, right, 5 over 12, it's opposite over adjacent. So I know that's a 5, that's a 12. There's my angle. It's positive, yes, so I know that's the first one. That's alpha. Where else is tan positive? Which quadrant is it positive? Quadrant 3. So I know that's my alpha right there in quadrant 3. Where it's negative 5 over negative 12, which would still give me a positive. It's the same thing, right? So the angle, 23 degrees to the nearest degree, that's also 23 degrees to the nearest degree. Well, the first one is 23 because we're not adding it to anything. This one was 180 plus the 23 for a grand total of 202.6 or 203 if I round it, right? So far, so good. What's the question actually asking, though? Because I think I just did the second part. I didn't even read the question. It wants the other ratios. So, 5 and 12, right, opposite over adjacent. What's my hypotenuse? All right, which is 25 plus 144, which is 169, which is 13. So what's my sin? Yeah, opposite over hypotenuse, so it's going to be 5 over 13. My cos is 12 over 13.
What is the alpha for? Is that just like a...
That's just x, y, theta, theta cat, sailboat. It just indicates that it's an angle. That's all. It's a variable for an angle. It's so fast, I am sorry. That's where they ask you in the next one.